Hello students, today we are going to study the automatic voltage control system in detail. As a kind of online grid reactive power dispatching system, it has been rapidly applied and developed in recent years. It plays a positive role in optimizing the reactive current of the regional power grid and improving the grid power supply level. First, what is automatic voltage control? Automatic voltage control is a regulation process in which reactive power voltage optimization is carried out by taking the voltage qualification of each bus in the system as a constraint condition and issuing control commands to the equipment. What is the basic structure of AVC? AVC system generally consists of a master station and a substation. The master station is installed in the dispatch center of the regional power grid. The substation is installed on the side of the power plant. According to the calculation of the system reactive power optimizing current, the AVC master sends the node voltage control command to the substation and receives the feedback status information from the substation. The AVC substation can be divided into the master computer and the slave computer in terms of functional logic, and the target reactive power of each unit is issued to the slave computer. Figure 1. System schematic diagram of AVC. So what does the AVC target control model look like? Let's take a look at the AVC target. Control model schematic. After the power plant side substation receives the target control value node voltage from the main station, it carries out plant-wide reactive power calculation and allocates the target reactive power to each unit. The quantity of reactive power regulation control of the unit depends uniquely on the target control value of the master station. The operating status quantities of each unit, such as machine terminal voltage, plant bus voltage, active and reactive power of the unit, etc., are only used as safety blocking conditions to determine whether to allow AVC regulation or not. This control mode is very different from the traditional single-modal AVR control mode. Each power plant presents different problems under the regulation of the AVC system due to the differences in the reactive power environment in which it is located. So, what are the impacts of AVC on power plants? First is the impact on power plants near load center. As load center consumes more reactive power, when the grid supporting reactive power regulation measures are insufficient, the AVC system will certainly require the nearby power plant to increase reactive power to meet the requirements of maintaining the voltage level of the grid. If the grid reactive power deficit is relatively large, the AVC will continuously increase the reactive power output of these plants until the relevant parameters of the generating units, such as voltage, current, reactive power, etc., reach the blocking values. Frequently in this operating condition will certainly have a great impact on the power plant, such as accelerating insulation agent. Generating units often send out a large amount of reactive power. The plant voltage will be high for a long period, which will certainly accelerate the agent of the installation of electrical equipment and the risk of installation damage. During the peak period of the grid load, the active and reactive power issued by the power plant is at a high limit, and the plant bus voltage will also be at a high level of operation. After turning into the load-through operation, the active and reactive power demand of the grid will drop. At this time, the active output of the power plant will be reduced, and the plant load will be lowered accordingly. If the reactive power regulation instruction issued by AVC remains unchanged, or the regulation of reactive power reduction is not strong enough, then the plant bus voltage of the generator will certainly rise, even exceeding the limit value of the permissible operating voltage of the electrical equipment, which may cause individual or even large area damage to the installation of the electrical equipment, endangering the safe operation of the generating units. The second is the impact on power plants far from load center. Electricity from power plants located far from load center often has to be transported through very long high voltage lines. These transmission lines can be hundreds of kilometers long or tens of kilometers short. Long high voltage transmission lines become the grid's large capacity reactive power sources. Power plants located at the end of the line are rich in reactive power, as evidenced by the long-term high voltage at the bus bar of the booster station and the plant bus bar. When the grid voltage is relatively high, the AVC system will definitely require the power plant to absorb reactive power. So it will continuously issue the AVR of the generating unit a magnetization reduction command until it achieves the target control value set by the AVC, or triggers a certain safety blocking condition. The plant bus is at the end of the load of the power plant, and therefore it is first to block. The AVC regulates mainly the low limit of the plant bus voltage and the low limit of the plant bus voltage of the AVC substation. Is generally set at the lower limit of the permissible long-term operating voltage of the electrical equipment. The plant bus voltage often operates near the low limit value, which possesses a great risk to the safe operation of the unit. If the plant bus voltage has been operating at the lower limit of the set value under AVC regulation, when the operating condition of the generating unit changes from low active and low reactive power at the loading through to a highly active and low reactive power at the load peak, the plant load will rise accordingly, and its plant bus voltage will surely fall. This drop in voltage is not regulated by the AVC system, but is a natural result of load variations. The AVC system is not capable of blocking if the plant bus voltage drops too low. It may cause certain equipment that is sensitive to voltage to trip, jeopardizing the safety of the unit. AVC system is a new type of global control system, which plays a positive role in optimizing the reactive power distribution of the grid and improving the system voltage level. However, because its control mode is very different from the traditional single machine control mode, it brings certain safety risks to the safe operation of generating units. Power plants can take targeted measures to eliminate the impact of AVC systems on power plants. Well, class, that's it for today's lesson. See you.